All right. Hey, friends. So, um, this video is going to be about randomizing sounds. And this is in 425. So, if you're in a previous version, maybe there's something missing. If you're in a future version, maybe there's something more. It's just the way it goes. But yeah, what I wanted to sort of talk about here is different ways of randomizing sounds. I think randomization is probably the most common thing we have to do in the sound world, and there are different reasons and different ways that we might want to approach randomizing sounds. But from the simplest to the more complicated, there's all different reasons why we might want to choose one way or another. So I'm just going to explore a bunch of different ways that we can randomize sounds. Just so that people don't feel like there's only one way, or if you've only been doing something one way, then maybe this is you could change it up or try something different. And there's implications for picking one way or another. So here I have a bunch of Ren recordings that I captured with my RO7 one day when I was walking to work. And they're slightly different from one another. It's a good candidate for a randomization. So the old school method would be to use a sound cue, right? So here I can build, say, a sound cue, and I can call it my bird tweet. And then double click in the sound cue. And then with all of these, let me shrink my deal there. With all of these sound waves brought in here, I can open up my SoundCue graph, right click, and then select random multiple waves, and it will automatically create a random node inside the SoundCue graph. I can play the node to check it. Yep, that's working. Cool. And then I can add, my classics, the modulator node as an example, and then tweak my pitch values and my volume values in a way that I like. And then this is like probably the most classic sound cue, right? And we can audition each path, which is kind of cool. I like the graph, is kind of fun to work in. So now we can play it. Now we have like a single point of connection for all of that randomization. And we can call this, we can call play on this sound just like any other sound. Sound waves and sound cues are both childed off of what we call sound base. And if we look at our blueprints, this is just a standard third-person template, so there's nothing extra in here except for my bird sounds. If we look at a blueprint call for, say, play sound, we'll just say play sound 2D as a simple example. This type, the input type, you can see here it says sound base object reference. And so sound base includes sound wave as a child and sound cue as a child. And also, under the hood, there's actually, when you use a dialogue, there's separate functions for it. But the dialogue wave actually generates under the hood a sound base, which is basically the sound that it selects, right? So in a roundabout way, even dialogue has sound base somewhere down there. But it is a different type because there's a special bit to it. But other than that, the sound cue and the sound wave are both sound-based children. And so when I select an asset type, you'll see both sound cues and sound waves. And here's my bird tweet. And so this function call would actually just play my bird tweet. Cool. So there's another way we can use SoundCue, and that is with a SoundCue template. Now, SoundCue templates were made as a kind of helper on Fortnite. Fortnite had a bunch of sound cues that were basically structured the same way. And the SoundCue template system was a way for sound designers to have sound cues that all share the same graph. Because here you've got like random selection and a modulator, and it's like if I create two of these, then if I want to make changes to them, then I have to go to two of them, right? Like, say if I have to rein in the volume modulation or something like that, then I have to edit two of them. If I have 1,000 of them, I have to edit 1,000 of them, which is very painful. So that's sort of one of the frustrating legacy aspects of SoundCues. So a SoundCue template is kind of like an intermediary way to help stop the bleeding, so to speak. And so to access SoundCue templates, you'd have to turn on the SoundCue template plugin. It's under audio. Scroll down. We enable SoundCue template plugin. We say yes. We restart. We don't need to save that map. We get to look at my Ghibli background momentarily. Okay, now SoundCue templates are activated, and I can create if you look under sounds, a SoundCue template. Before we can begin using SoundCue templates, though, we need to set up some settings. So if we go to our project settings, and then under the game, we see SoundCue templates. We just have to add a default quality level. And this is basically necessary for the container object, because the container object is it generates branches based off of quality nodes. So if you're doing a multi-platform SKU title, then you may find yourself needing to branch your sound cues based on your target platform, right? So high-end PC or high-end console, you could probably have a whole bunch of sounds playing at once. Whereas with a mobile device, you may need to have a consolidated version of your SoundCue graph. So this is a little method of branching. So when we create our SoundCue template, it will instantiate, some of them may instantiate quality level differences of branching. So we need to set our quality levels up in advance. And for now, we'll just set up the default, and we will add max randomized variations. Let's say we can have 12. Sure. And we'll just go 12 across the board. I think that's my memory guess of how many variations I had of this bird tweet. Well, let's see. Select them all. I have 15 items selected. So what? 15 items selected. No. 11 items selected. So I was very close. Okay, so now that we have our quality level setting set up, we have one quality level set up so far. That's fine. We're going to create a SoundCue template of a container type. So I'll select that, and this will be my bird tweet container. Let's call it that. And if I double click on this, you'll see just a data asset type with a little randomize set. And this container type could be concatenation, randomization, or just a mixer node, right? This represents a classic node in our SoundCue graph. So a randomized node is an example. That's what we're using. None of these sounds are looping sounds. That's fine. So we'll just select them. And I believe we can now select and drop them on the set. Can we do that? Will it let me do that? It won't let me do that. Okay. Well, that's a bummer. Well, let me do this now. They must have only done that for arrays. So, we'll have to talk to someone at editor about that, because that would be handy to be able to drag and drop sets as well, right? Why not? Especially drag and drop with a multi-selection, because obviously you have unique selections. So the set, I would imagine, would intake uniques, and of course you could also do it maybe where if there was a duplicate, it would just reject it and continue on to the next item. Anyway, right now this is not too painful. But anyway, so here we have our container. It's randomizing between our birds. And then we have, our classic modulation. And I think in our original volume modulation range was something like 0.95 and 1.05. Oops, not 10.5. 1.05. There we go. So I save that. And I press play. There you go. This is my Ren. And my SoundCue. You'll actually notice that the SoundCue is a little bit quieter. And that's because SoundCues actually default with a volume multiplier of a little bit under, not quite 3 dB, negative 3 dB, but almost negative 3 dB on the volume multiplier. But otherwise, it's basically the same. And the only thing that you'll notice is not part of this, which, all of that can be added, is our classic sound base, other sound base stuff like sound class and all that sort of stuff. All of that, of course, can be set on the sound waves themselves. It's just that the SoundCue overrides that stuff. But what you noticed that when I set SoundCue template, there were only 2 types. If you have a programmer on your team, you can add types, and they can take a look at the SoundCue template code and actually just add custom types. So if on your game project you find yourself using the same graph topology over and over and over again, then it might be worth looking at a SoundCue container instead of a SoundCue. And the big reason being, of course, that you have more options in terms of batch editing. So, for example, if I right-click here and just hit edit, you'll see I'm actually editing 2 assets at once. And with SoundCues, you don't get that. You have to edit both of these, and they will open up 2 different windows, right? So that's where things can get kind of sticky, because batch editing SoundCues is a very painful process. And if you're knee-deep in a project and you're knee-deep in SoundCue land, then that's sort of a pain point. Now, that's not the only way. We could create our own custom sound selector type, and we can use whatever logic we want on it. And that's sort of the power of blueprints. So here I will actually create a data asset. And in order to do that, I will create a blueprint class, and I will select all classes, and I'll select data asset, and I'll select primary data asset as my type, and then I will say Dan's random sound selector. Cool. And I'll double click here. And what I will do in this is I will create a variable of sounds. And the type will be, here, we'll do it over here. The type will be a sound base. and we'll make it an array. We know arrays are super easy to work with. And yeah, you can make that public. It doesn't really matter. And then let's make a function. Oh, what was the other thing? Volume and pitch modulation, right? So let's do a, let's make this our pitch mod range, and we'll make it a single asset of a vector 2D. Boop. And a vector 2D is just an X and Y float. And then we will also make, we'll duplicate this, volume mod range. And let's add some sensible initial values. So we'll go 0.95 and 1, not 10. I keep doing that. 1.05. Those are our classic values. 0.95, 1.05. Cool. And then we will create a function that will be that we'll just call random sound. And what we'll do is we will select an output, and the output will be the first parameter output will be sound base, and then we'll just call this the sound, and then a float parameter that is our volume, and a float parameter that is our pitch. And then we'll do this the simple way. But we're just going to get this. We're going to get, and then we'll get the last index. And then we will do random integer and range from 0 to that. And then we will check is valid. And I think if it's valid, let's do this. We'll just do a little cache. We'll say local sound. And then what we'll do is essentially is that this will be null if there's no sound. So if the array is empty, basically. And then our volume is random range, and our pitch is random range. Right? And then what we'll do is we will get our pitch mod, get, and then split the struct, and then just go X to min, Y to max, get, split struct pin. Look at that. Beautiful. Okay, so now we have a type of data asset called Dan's random sound selector. And then if I right click and I go to miscellaneous and I say data asset of type, and then you'll see Dan's random sound selector. And then I'll go bird selector. And I'll right click, and then here I can actually, because it's an array, I can actually just drag and drop right there. Bam! Save it. And now what I will do is I'll create a little script to play it, and you can see how that works. So I'm going to accept input. So when I type input 1, when I type 1 on the keyboard, it'll play this sound. And we will play sound. We'll do play sound 2D, just to keep things simple. And then when it's pressed, it'll play this sound. But first, what we want is one of our fancy selectors. We'll just call it my selector. And it's of type Dan Sound Selector, right? And we can even find it now. Our bird selector is there, so boom. We get it. We right click, validated get. Okay. And then what we'll do is we'll call that function. What did I call it? Get random. What did I call it? Random sound? I just called it random sound. I probably should have called it a get. Anyway, plug, 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 plug. Bam. There you go. Right? We press play. I hit 1. There's my bird. It's a random bird. And if we look at our stat sound waves, we can see that it's playing. That's 4. This one's 3. It's playing 9. Playing 8. So there you go. That's a random. So, you know, using this approach, this data asset approach, can be super powerful. And what's even more powerful is that these are sound bases. So I can also include other sound cues, right? So I can mix and match as I wish. And it only unlocks more and more and more. You know, for example, I could create a blueprint class, which is basically my bird selector. I'll just make it an object class. So I'll make it advanced sound selector. All right. And then here I will create my sounds. This is my random array of sound bases. Let's make it an array. I'm going to make this public. And then we had a volume mod range. Let's do the same thing as we did before. Vector, vCore, vector 2D. Make that public. Pitch mod range. Also make that public. And we'll give them, you know, good default values again, like we had before. So that you know, so that the user, which is you and your team, will get, you know, out of the box, things will work as they would expect. All right, so that's plenty good. So now we need again a function. We'll call it proper get random sound. Get random sound. Okay, and then here's where we will get interesting, because I'm going to add a variable called be initialized. And I'm going to make it a Boolean variable. And then I'm going to also create a function, or create a variable. Let's see how I want to do this. We will do a let's say we'll call it shuffled sound. I'm kind of making this up as I go along. Shuffled sounds, and we'll go. Actually, can reorder it as needed, right? Well, that public variable, it'll be the instance. So I'll be good. So I won't even do that. Here's what we'll do. Sorry. So what I'm basically doing is creating some additional functionality. Okay, and this functionality is basically a shuffling functionality. So here I'm going to essentially have it so that it will shuffle itself. It gets a random sound. If you ask for a random sound, like, give me a random sound, and then it'll start keeping track. Or rather, it will shuffle the deck, so to speak. And we just want to shuffle the deck every time that we run out, right? So we just want to keep track of current index. I think that should be fine, and that'll be an integer. And what we'll do is we'll create a function called initialize, and we will make it private. A private function just means that no one else can access it. And then what we'll do is the initialize will just basically shuffle the deck. So what we'll do is we will take our sounds. We will copy them. We're going to do this a very simple way to a local array sound. We'll just say a local array. And then we want to rearrange the shuffled sounds. So we just want to change the order. I don't even know if I need to, maybe I don't need to copy it. Sorry, I'm doing this on the fly here. Let's delete it. And then I'll see if I can go through it without copying it. This is one of those computer science questions that I would probably fail on an interview. Oh, you know what? They have a shuffle. Oh my god, I'm dumb. I forgot they added a shuffle function. Look at this. It's even easier than I could have imagined. I was all here about to build a shuffle function from scratch. Okay. All right. And then we set initialized. Okay, cool. And then what we'll do is every time we get a random sound, we will we will branch if we have been initialized. We will just get the current index. So get current index. Let's put this up here. Oh, I forgot what my output of this function. So let's select here. I forgot to add my outs. Okay, so we have our sound base, which is our sound that we've selected. So we'll call it our sound. Then we have our volume and our pitch. Okay. So let's cache that in a local variable. We'll just call selected sound. Boom. Okay. So if we haven't initialized it, oh no, sorry, we have initialized it, just get the current index. Totally cool. And then what we do is we will take the current index. And we will go plus plus. Oh, actually, we will go plus integer. Oh, you know what? We should probably validate this first. Is this? Can I do a validated get from this? No. So let's just check it is valid before we start grabbing them. We just want to make sure that it's real. I just want to know that something in the world is real. Okay. Then our current index is incremented. All right. But our current index is incremented by 1. And then what we will do is we will modulate. That's the percentage sign. This is A mod B. And that's basically the remainder of a division. So I'm going to essentially divide whatever the value is. So let's say our current index is 0, and then I go plus 1. Now our current index is going to be 1, right? And then I will take 1 and divide it by sorry, I'm grabbing the wrong thing. Off the array, last index. So the last index, all right? And here, let me move this up here so it's out of the way. It looks a little bit cleaner. Basically, what this is going to do, let's say there are 3 items, all right? That means the last index, sorry, not the last index. It should be the length. Length. So let's say there are 3 items. That means length is 3. So the indices are 0, 1, and 2. So what's going to happen is our current index, which starts out as 0, we're going to add 1 to it. Then it's going to be 1. And then it's going to go here, and it's going to be 1 divided by 3. Now, the result of a mod is the remainder. And 1 divided by 3 is a remainder of 1, right? Because you get 0, right? 1 divided by 3 is 0 with a remainder of 1. So it will go 1. So our next index will be 1, right? Then we get our sound again. Next time we get our sound, and then it will go, okay, our current index is now 2. 2 divided by 3 is 2. Or 2 divided by 3 is 0 with a remainder of 2. And then it'll pass the remainder off to the current index. And now the current index is going to be 2. And then we do this again. And then what's going to happen is when we go through this again, it'll go 2 plus 1 is 3. 3 divided by 3 is 1 with a remainder of 0. So I will pass 0 to current index. Mod, if you're an audio person, mod is the most important math function. It's used so much in audio that an audio middleware was named after that function called fmod. So Firelight named their entire middleware after this function. So it's super common. Get used to it. It's very, very useful whenever you're doing anything sort of sound or music related. Okay, so what this means is we'll never exceed our length, which is super useful. And if the length of this changes, then we will, let's do, if it's not valid, we'll still attempt to get a new index. Because maybe the length changed somehow. We don't know. Some user did some shit. Okay. Then we've got our new sound. We've incremented. Boom. We're good to go. Now, what if we're not initialized? Oh, that was one thing I wanted to check. Thanks for reminding me. We want one more branch. One more branch. And what we want to check is if current index doesn't equal, sorry, if current index doesn't equal 0. It's kind of a weird check, but basically, if it equals 0, that means we got to shuffle. So what I'm going to do is set initialized to 0, or to false. So it's no longer initialized. So that means we've wrapped around and we need to reshuffle. Boom. Cool. Yeah, let's do this reroute node. I just want to make this reroute. Reroute nodes are super useful. Boom. Boom. Okay, now, if we are not initialized, then we need to initialize. That's initialize. And now it's going to shuffle the deck. And then we can actually just resume our normal selection process. So we're now initialized, and we can continue. Then we're going to go through this, and anytime our current index reaches 0 again, it will reshuffle the deck. And it'll know to reshuffle the deck because we will have uninitialized it, essentially. We'll say that we marked it as not initialized. Okay, so now we just need to pass the selected sound. And then our classic, we've done this before, random range, random float range, copy and paste, random float range, get, split, boom, boom, get, split, boom, boom. Okay, so what I've created here is essentially what is meant to be a data blueprint. So what we can do here is now we want our birds. So I'm going to create a child blueprint class, and I'm going to call it my bird selector. I'll call it my advanced bird selector. All right. And then data blueprints are pretty easy to use. Open them once, close them, open it again, and it's just the data. All right. And then it's the same thing. Boop, boop, ready to go. And then we can use it the same way as our other data asset, except now our object, my selector, we'll call this my advanced selector, of advanced selector, sound selector type. All right, here it is. Whoops. Oh, it's an object. Okay. So I'm going to have to create a new one. But that's pretty easy. So we'll do begin, play, and construct object from class. And it's going to be my advanced sound selector. And then we'll just cache it. Boom. Right there. Oh, what is it complaining about? Doesn't like, can I go this? Yeah, that's fine. Okay, and then, then here what we'll do is we'll just paste this over there so you can kind of compare it. It's going to look almost exactly the same. Validated get. Right, boom. And then it was get random sound. Boom. And now what's cool is as long as this object, this advanced selector is alive in the blueprint, is cached here, as long as it's like that, it will always keep track of which sound it's supposed to play next. And every time it goes around the loop, it will reshuffle its deck. So if we want to, what did I do? Which type did I make it of? I'm not paying attention here. Advanced bird selector. Sorry. Boom. I press play. 1. There, it picked 8, 9, 3, 7, 2, 4, 6, 1, 5. See, it's not repeating any of them. 11, 10. Pretty cool, huh? Okay. So those are like different ways of just doing simple random selection. And what I've done in certain cases is created blueprints where I'm intelligently selecting. You know, for example, I created a footstep system where the footsteps were ordered in an array. So it was an ordered array of footsteps where they went from soft to loudest. And so then I created a blueprint where I randomly selected, say, 3 up or 3 down from a section of that array. And then I modulated which part of the array I was selecting from based off of my player's speed. Right? So, like, random selection is just the beginning. And when you start exploring different ways of selecting random stuff, you can actually start digging into even more cooler features. And that's something that SoundCues cannot do. So there's a wider world out there once you crack open and sort of crack your head out of the window of SoundCues and start looking around. So I encourage everyone to explore and try different things. So hopefully this was interesting, helpful, and random with any luck.